Jai Janendra, Namaste and welcome to my channel. Today we are going to solve the 78th question of the problem solving series and the 8th question of string. The difficulty level for this question is medium and this question has been asked in Microsoft, Google, Amazon, Nvidia and many other companies. Reverse words in a string. So we are given a string S in a string and we need to reverse the words that are present in this string. Let's look at the example. The sky is blue. Okay, so we just don't need to reverse the strings, we need to reverse the words that are present in the string. That means here we will give our it will start with the last word blue, then the second last word is, then sky, and then the, followed with space between every words, right? Also it could be given that there could be multiple space between two words and also in the beginning and the last word. Oh, it's given in the question that we should ignore these spaces and the answer that we will return, the string that we are going to return, should have only one space between word, as we always have in our English sentences, right? So hello world, it would be the last word is world and after that it's hello. So world space hello. So this spaces here it's given that there are two spaces, will not have space in our returned string. Okay, so now how do we solve this question? What is the approach that comes to your mind? So whenever we had a questions like reverse string, so if we had to reverse a string, we just need to take the string from the end last element of the string and store it and keep on adding it. We'll go from last to the first and we'll return it. But here we are not going to return this as EULP. Okay, it is, we'll return it as the same word, just the last word will come in the first, the second last word will come in the second. In this way we'll return. So how do we solve this? If we'll reverse it, then it will not help us. Okay, we can't reverse it and return it. Or else what we can do, we can just, what do you think? So we can take the word and then again reverse it. We'll start from the last, we'll get the word, and when we get the space we'll stop and we have our word EULP and then we reverse it. So it becomes blue. Okay, and then we store it in our result string. So if we are storing the result in, if we are returning RES, we are storing this blue. And then we can continue it. So in that way we can solve the question. Just the thing is that for every word will, whatever string we will get, whatever word we will get, that will be, we need to reverse it again every time. So that isn't that some extra effort, extra complexity? Can we improve it? Do we have any better approach? What if, how we will get this whole word? So instead of returning from the back and then reversing it to get the string, what can be done? So you know that if we, you know the stack data structure, right? So stack, you know, last in first out. So if we store this whole thing in a stack, so if we store this D sky whenever we get a word from the string and then we store it here, right? The sky is blue. And then when we return it, we will store, add this in a string. Result plus whatever is there in the top, we store. So blue is sky, and after getting the string, we'll put a space between it and we'll not add space here. So in that way, we'll just need a stack data structure. With the stack data structure, we can solve it in one traversal, order of n time complexity, and extra space would be order of n of stack. So we take a stack of string, okay? Because we'll store the word and we'll ignore the space, okay? So how do, let's solve this? Stack string S. So what we do, okay, so let's traverse this string for int I equal to 0, I less than s dot size and I plus plus. So now what we do, if we see that there is a space, okay, first we need to get the word, we need to try to get the word first. So let's take a string 10 to get the word, okay. So how do we extract the word from the string? What we can do, if the string Si is not equal to space, okay, if there is no space here, okay, space, then we can add it into temp, okay. If Si is not equal to space, then we add into temp plus equal to Si, but till when we get the space, okay, else, so when we get the space, then we need to stop and we need to see if else, okay, if temp is not empty, empty, okay, then what do we do if temp is not empty? This is a space, this is empty, okay. If temp is not empty, that means we have the we have got the alphabet in the temp now, we have got the word in the temp, so we push it into the stack dot push temp, right? We have got the word and then we make temp as empty, right? So we make the temp as empty. And what else? If temp is already empty, and if temp is empty and we get another Si as empty, so we just ignore it, okay. So actually it's like this, we don't care, temp is empty over here, we are adding it, and this will help us to get our stack, okay, and we will cross this, okay. Now after traversing it, when we see if still at the end, so when we will traverse BUE and temp will be blue, and since the size will be crossed of the string, so we see if temp is not empty, then again we need to push the last word into the stack, okay. Now we have string res, so what we do, we will traverse the stack while st dot empty, while the stack is not empty, then while stack is not empty, we store the words into the result, okay. So res plus equal to st dot top, okay, and then we can if stack dot size, if the stack dot size is greater than 1, because we don't want, okay, I'll explain what I have done here, res plus equal to space, okay, this is the space, and then we return res. So what we have done here, that once we have got this stack, okay, so here the stack is not empty, we have this as stack, so blue will be added to the result. After adding blue, we see the size of the stack. If the size of the stack is greater than 1, then we add a space. So after blue, we'll add a space, and then again we'll add the next letter is. Why we have added this? If we would not have added this and we would have directly given the space, then after blue is sky, there will be another space, okay. We don't want this extra space, okay. So that's why we need to check if the stack size is greater than 1, that means 2 are there, then we'll have one space. If the size of the stack is 1, so after that, the last word after reversing, we don't want space after that. That's why we need to add this condition. So this kind of edge cases you need to think, okay, and you need to add this, okay. So the link to the question is given in the description. Please try it yourself and then come to my code walkthrough section. Here is the code walkthrough of the 78th question and the 8th question of string, reverse words in a string in the LeetCode platform. You can see the difficulty level is medium, and this question has been asked in a lot of companies, you can see, okay.
In these last 3 months, it has been asked in Microsoft, Amazon, Meta, Google, Apple, Nvidia, all the big companies. Okay. So reverse words in a string, we have already discussed this. We've taken stack, string, empty string. We traverse the string and we make the word. And once we get the word, we push the word to the stack. We make the string as empty here. Okay. And then once we have traversed it, we add the last word, same as we have discussed. We get the string result. Okay, I forgot to add the stack.pop. Okay, so once we get the first element from the stack, we need to pop the stack, right, so to get the next word. So yeah, stack.pop is important. Okay, so yeah, that's self-understood also. So yeah, I'll submit this. So it has been accepted. Okay, see you also in the next video where I'll be explaining the 71st question of the problem solving series. Jai Jinendra.